This week we're going to be talking about geometric sequences. We've learned that sequences who have consecutive terms have a common difference is called an arithmetic sequence. In this section, we will study another important type of sequence called a geometric sequence. Consecutive terms of a geometric sequence have a common ratio, okay? Not a common difference, but a common ratio. Definition of a geometric sequence. A sequence is geometric when the ratios of consecutive terms are the same. So the sequence a sub 1, a sub 2, a sub 3, a sub 4, dot, 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 is geometric when there is a number r such that when we multiply by that, we get the next term. So for example, if I said that I gave you this term, oops, I better turn my marker on here, 2, and, whoa, that did not make my marker work. 2, and then my next term, whoops, let's say that my first term is 2, my next term is 6, my next term is 18, dot, dot, dot. Is this a geometric sequence? Well, how did I go from 2 to 6? I multiplied by 3. How did I go from 6 to 18? I multiplied by 3. If I multiply by 3 again, okay, what is that going to give me? 54? Would be my next term. And if I multiply it again, this is a geometric sequence. We're multiplying the first term to get the next term, and the next term, and the next term, and the next term. We could geometric sequence could go down. I could start with 100, 50, 25, 12.5, dot, dot, dot. What am I doing here? Well, I'm multiplying by 1/2. The ratio would be 1/2. Because 100 times 1/2 is 50, 50 times 1/2 is 25, 25 times 1/2 is 12.5, so on and so forth. So a ratio, it could be, the sequence could be increasing, it could be decreasing. It all depends on what the ratio is. If the ratio is greater than 1, it's going to increase. If it's less than 1, it's going to decrease. The nth term of a geometric sequence is written as a sub 1 r to the n minus 1. Okay, so for example, let's go back to the sequence 2, 6, 18, 54, dot, dot, dot. If I wanted to write an equation for this, it's super simple. All you do is you take the first term times the r value to the n minus 1. Well, the first term here is 2. My ratio is 3, n minus 1. So let's see if this works. If I wanted to find the first term, all I do is I plug 1 in here. 1 minus 1 is 0. 3 to the 0 is 1. 2 times 1 is 2. Oh, that is the first term. If I put 2 in here, 2 minus 1 is 1. So 2 times 3 to the first, well, that's 2 times 3, which is 6. Oh, and so on and so forth. So to find the nth term, super easy when you're dealing with a geometric sequence. So this week our objectives are to find the terms of a geometric sequence, including the geometric means, and find the sums of geometric series. Determine whether the sequence could be geometric or arithmetic. If possible, find the common ratio. Okay, so now it's really easy to find the ratio. All you have to do is take two numbers right next to each other. So 1 divided by 5 is 0.2. That would be my ratio. And you can take any two numbers. I could take 0.04 divided by 0.2, and you'll see that it comes out to be, 0.04 divided, just any number. I could go 0.2 divided by 1. That gives me 0.2. 0.04 divided by 0.2 is 0.2. So it doesn't really matter. You just take two numbers next to each other and divide, and it will give you the ratio. So this is a geometric sequence, and the ratio is equal to 0.2. So a practice problem, it says, determine whether the sequence 6, 18, 54, 162 is geometric. If it is geometric, find the common ratio. Okay, so in order for it to be a geometric sequence, every term has to give you, if you divide, so 162 divided by 54, 54 divided by 18, 18 divided by 6. They all have to give you the same ratio. So I'll get my trusty calculator out here. So 162 divided by 54 is 3. 54 divided by 18, that's 3. 18 divided by 6, that's 3. So they all have the same ratio. So this is a geometric sequence, and the R value is 3. Okay. Determine whether the sequence is geometric. So I've got 27. Oh, now it goes back and forth from negative to positive. -9, 3, -1. Again, it doesn't matter. Now, I know if it bounces back and forth from positive, negative to positive, negative, then I know my ratio has to be negative. Okay, that's the only, because when you multiply a positive times a negative, you get a negative. Then you go here. Let me give you an example. So if I said 2 is my first term and -3 is my ratio. Well, how do you find your next term? You just multiply by -3. So 2 times -3 is -6. Then my next term would be -3 times -6, which is positive 18. My next term would be -18 times 18 times -3, which is -54. So it's bouncing back and forth, positive, negative, positive, negative. That means your R value has to be negative. Okay, that's just one of those things. So in this problem, it looks like if I did -1 divided by 3, or 3 divided by -9, or -9 divided by 27, what's my ratio? -1/3. 3 over -9, -1/3. -9 over 27, -1/3. This is a geometric sequence. And my ratio is -1/3. So finding if something is a geometric sequence is fairly easy to do. Finding the ratio is also very easy to do. Each term of a geometric sequence is the product of the previous term of the common ratio, given the recursive rule for the geometric sequence. Okay, so a recursive rule is just going to be a sub n times, now this was our explicit rule. Okay, explicit is a sub 1 times r to the n minus 1. Now if we want to write a recursive rule, then it's the previous term times r. That's all it is. Okay, so a sub n is just going to be the previous term times r. Rarely do you ever use the recursive in geometric sequences. Rarely. Usually we use explicit formulas because now you can find any term. So if I wanted to find the 10th term, I just put 10 in for n. Here, to find the 10th term, I have to find the first, the second, the third, the fourth, the fifth, the sixth, the seventh, the eighth, the ninth, the 10th. That's why recursive formulas are not usually used too often, because they're not as useful as explicit formulas. So this is my explicit formula. A sub n is equal to a sub 1 times r to the n minus 1. So here it says find the 7th term of the geometric sequence. Okay, so I could write an equation if I wanted to and put 7 in there. We'll do it both ways. I'm just going to go, it looks like my ratio is 4, because 3 times 4 is 12. 12 times 4 is 48. 48 times 192. Okay, so I'm just going to, so this is the first term, second term, third term, fourth term. So I need the 5th, the 6th, and the 7th. Okay, so I'm just going to multiply 192 times 4, and that gives me 768. It's my 5th term. Then I'm going to multiply that by 4, and that gives me 3072. That's my 6th term. Then I'm going to multiply that by 4, and it gives me 12,288. Okay, so that's my 7th term. That wasn't that hard to find. Now, if it asked me for the 70th term, I probably wouldn't do that. But let's write an equation. My first term is 3 times my r value, n minus 1. So if I wanted to find the 7th term, I plugged 7 in for n. So that would be 3 times 4 to the 7 minus 1. So that would be 3 times 4 to the 6th power. So remember, we have to do our exponent first. So I'm just going to do 4 raised to the 6th power, and then multiply that by 3. And lo and behold, I end up with 12,288. So both ways, I get the same answer. It didn't ask me to write an equation for it. It just asked me to find the 7th term. So I could have done it either way. Okay, here it says find the nth term of the geometric sequence with the given first term and the common ratio. What is the fifth term? Okay, well, if I wanted to write an equation here, I could go 5/3 times -1/3 to the n minus 1 power. It wants the fifth term, so if I put 5 in here, okay, so I've got 5/3 times -1/3 to the 5 minus 1, which is 4. Okay, so I have to do -1/3 to the 4th power first. So I've got 1/3 raised to the 4th power. I don't know if my calculator, I've got a really cheap calculator, times 5 divided by 3. I come up with, oh boy, I guess I should have left it as a fraction. Okay, so I'm just going to do it this way. 5/3 times, well, -1/3. If I take it to the 4th power, so that's going to be +1 over 3 times 3 times 3 times 3, 27. I don't want to make a mistake here because that messes you guys up. 27, so that's 81. So if I do this out, I end up with 5 over 81 times 3, which is 243. So this is what I would end up with, 5 over 243. So it looks like this answer here. Okay. Write the first 5 terms of the geometric sequence. Okay, so it gives me the first term is -3. Tells me my r value is -1/4. So all I have to do is multiply this by -1/4. So that's going to be +3/4. That's my second term. My third term is going to be multiplied by -1/4. So that's going to be -3/16. Then it's going to be +3. Okay, and see what's happening. The top is always going to be 3, but it's going to be -3, +3, -3, +3, 1, 2, 3, 4. So that's going to be -3. So 16. So 16 times 4 is going to give me 64 down here. Times 4 is going to be 256. So it looks like I've got -3 over 256. Let's see here. So 3/4. Oops. So that's my first. Oh, I could have stopped right off the bat. So -3/4. I'm going to go with letter A there. Okay, then we're going to find the sum of the first n terms of a geometric series. This is a kind of a weird formula. S of n just means that you're looking for the sum. A sub 1 is the first term. 1 minus r to the n over 1 minus r. Okay, so that formula, it gives you the sum of the first n terms of a sequence. So let's just, I always like to just use an example. So let's say I gave you this sequence, 2, and let's just multiply by 2. So our r value, so a sub 1 is equal to 2, r is equal to 2, so my next term would be 4, my next term would be 8, my next term would be 16, and let's just find s of 4, okay? Because I can find s of 4 real easy, I can just add this up. So this would be, what, 10, so that would equal 30. So s of 4 would equal 30. Just by adding these 4 terms up, I get the sum of the first 4 terms of this sequence is 30. Now let's use the formula and see if we get the same thing. So a sub 1 is 2. 1 minus r, well, our r value was 2, right? To the nth power, well, that was to the 4th power, over 1 minus r, so that's 1 minus 2. It doesn't look like this is going to equal 30, but let's just try it. So I've got 2 on the outside, and then 1 minus 2 to the 4th. Well, 2 to the 4th, 2 times 2 times 2 times 2, so that's 4, 8, 16. So 1 minus 16 over 1 minus 2, which is -1, isn't it? So 1 minus 16 is -15 over -1. So -15 over -1 is 15. So 2 times 15 is, it's 30. It's the exact same answer as I got there. So this formula does work. It's a little putsy there, but it does work. So here is an example. It says find the indicated sum for the geometric series 1, 2, 4, 8, 16. Oh, they did the same formula, or the same one that I did, except they did S of 8. So they wanted to know what the sum of the first 8 terms are. Okay. So if I was going to write this down, it would be 2, and then 1 minus 2 to the 8th power over 1 minus 2. And if you plug that into your calculator, they come up with 255. Okay. So we can find the sum of a series just by doing that. Now, if they give it to you in this form, remember, we can find the first term. We know the nth would be 6. So in this problem right here, you know, there's really a 1 out in front here. So we could always, oh, this one is starting at 1. So yeah, we could always find the first term. And the first term would be 1. We know the ratio is 1/2, right? So now we could just plug that in, and we know that we're finding the sum of the first 6 values. So you could just plug that into our formula and get 1.97, or use a calculator and do the same thing. All right. I think there was an infinite. I think there was one more formula that we needed to know this week. Okay. So now, that is the sum of a specific number, a finite number of values. Okay. So let's say they asked us to find the sum of a geometric series that goes on forever, an infinite number. And some people would say, well, wouldn't the answer always be infinity? It would not be. If the R value is greater than 1, okay, the R value is greater than 1, the value will always be infinity. But if the R value is less than 1, then, okay, so let's do an example. Let's say I gave you 10, 5. Oh, darn it, I should have. I'll start with 40. 40, 20, 10, 5, ... And we're just going to add a zillion of these numbers together. Some people would think in their minds that the answer would be infinity, but it's not, because we keep getting smaller and smaller and smaller. It's not. So if I was going to do this problem, I look at this, and 40 plus 20, that's 60, plus 10 is 70, 75. I'm thinking the answer might be, because then I'm going to add 2.5 to that, and then I'm going to add I'm thinking it's going to be close to 80. But I don't know for sure. So this formula tells me that if I take the first term over 1 minus r, where my r value was 1/2, wasn't it? 1 minus 1/2. Well, 1 minus 1/2 is 1/2, so this is 40 over 1/2, which is 80. The sum of all these numbers added together, an infinite number of them added together, would add up to 80. That is just mind-blowing for some kids. But when you think about it, you're adding a smaller and smaller and smaller number onto that. It has to converge onto a specific number. So if I give you this problem, it says find the sum. N is equal to 0 to infinity of 4 times 0.6. Well, that tells me that my first term is 4. My R value is 0.6, so this is just 4 over 1 minus 0.6, which is 4 over 0.4. And 4 divided by 0.4 is 10. So if I added a zillion of these numbers together, the sum is going to be 10.